Welcome back to V-Spice. In this session, we'll continue with the fugitive emission. We'll focus the part B. Part B, we focus why fugitive emission needs to be controlled. uh, and also we'll touch upon the thermal leak mitigation. And finally, we also focus on the standards actually. We'll just run through the standards, like standard in the sense API and also the ISO standards. Okay. So, hope you're aware that the first part we covered the what is fugitive emission and the terminologies involved, and most importantly, the sealing types of valve stem. So, in this session, we'll talk about why reducing emission is required, and thermal leak risk mitigation, and finally, we wind up with the emission testing standard. Okay, so why reducing emission is required? Yes, fugitive emission contribute to air pollution as harmful gases escape via vessels, valves, etc. Isn't it? So it create risk and hazards. What are all those risk and hazards? Yeah, emission of volatile organic compounds from refineries and chemical plants create risk for local communities and workers, right? Yes. So in cases where large amount of flammable liquids and gases are contained under pressure, it creates a possibilities for explosion, isn't it? Yes. So we need to be very watchful to reduce this emission. And valve is a major component of piping system, isn't it? So it's used every industry, right? So it can create a toxic one working environment if fugitive emission is not controlled, because the leak through it, and human like operators, so they will also inhale, and that will cause a lot of issues, health issues, all these, right? So long duration emission starts leakage along the shaft or the stem. That is a point actually, stem of the valve. And this stops the gas or liquid being controlled from leaking. So if there is a leakage, so we can't control, right? So we need to be very watchful about this reducing emission. We can't just like that ignore. So ultimately, it increases the economic cost related to lost and damaged materials also. So these are the various reasons actually why reducing emission is very, very important, right? So now we'll talk about the thermal leak risk mitigation. Thermal leak happens after the thermal cycle in a chemical process. Okay, what is thermal cycle? All we have covered in the previous session. You can watch and come back to this. Okay, so thermal leak basically create a path at the body in a critical service condition with extreme pressure and temperature fluctuation. So that is a point. So thermal leak create a leak path. That is a point. So it is important to check with the vendor whether he has tested and gathered this data. Very, very important for valves, I'm telling. Valves and of course all equipments also. So to eliminate the suspected leak risk in thermocycle, below points to be considered during the valve selection. So what are all those points actually? Yes. So we need to consider PTFE type body gasket, Teflon, basically, right? This is the look and feel, right? So it's a good choice for stable temperature, but a thermal cycle will cause, if it is subjected to thermal cycle, it will cause the PTFE cold flow, and it reduces the compression, right? So results in leak. That is the one of the drawback actually. Okay. And when we talk about the graphite type body gasket, this one, it works well at most temperatures actually, no worries. And it handles many thermal cycles, so better than this, right? Okay. But usually required to achieve fire safe rating on the valve. If you are using this, you need to achieve the fire safe rating on the valve. That is the point you need to take care. Friends, we are talking about the thermal leak risk mitigation. What are all the aspects? One is way of doing this, PTFE type body gasket. Other is the graphite type body gasket. Okay, then few more. Dual material body gasket. So basically it's a combination. It combines the benefit of Teflon and graphite to provide a inert seal that can protect against fugitive emission and also ensure the fire safe operation. So that also met. Okay, this is the dual material. As you can see here, dual material. Then the final one is a spiral bond actually, not final one. Yeah, the fourth one, spiral bond. So if you look at the one, you see You see the spiral, right? Yes. So basically it provides a proven design, it provides structural support and live loading via metal spring V-shaped ring actually. So the live loading mechanism also we explained in one of the separate video. If you're interested, you can go to the playlist control valve design specification. In that we have covered that extensively. Okay, right. So most of the spiral wound gasket use either PTFE, Teflon or graphite seal material. Okay. So this is the fourth item, body gasket, spiral wound. Then a few more to add on the spiral wound. Dual gasket material in the spiral wound configuration is very chemically resistive actually. That is the advantage and able to recover itself after thermal cycle and operate uncompromised in all temperature ranges. So that is the beauty of using a dual material gasket. Okay, so basically it's a chemically resistive. So that is good for thermal leak mitigation. Then self-relieving seats actually. And this is the look and feel of the self-relieving seats. So it's designed to relieve the excess pressure built up in the valve because trapped fluid in its cavity. Under specific condition, the trapped fluid actually, in a fully closed valve expand and results in high pressure and create a potential leakage. So that is why we need this, this radial groove, the internal groove for releasing the pressure buildup. Okay. So these are the 5 methodology wherein we can, mitigate this thermal leak. You got it, friends? Okay, good. Now we talk about the fugitive emission standard. Standard in the sense ISO and APA. So in ISO, we have ISO 15848 part 1. So it basically talks about the qualification procedure for fugitive emission test for valves. So valves in the sense rotary and rising stem. So basically it talks about the qualification procedure ISO 15848 part 1. Then we have ISO 15848 part 2. It talks about the acceptance criteria for fugitive emission. So what are all the acceptable level? We talked about, right? 500 ppm, 100 ppm, all those in the previous videos, right? Yes. So that criteria is detailed out in ISO 15848 part 2. Then when we talk about APA, American Petroleum Standard, API 622, it talks about the process valve packing for fugitive emission. Process valve packing, valve packing, okay? That is for fugitive emission. Then APA 624, it talks about the rising stem valve fitted with graphite packing and tested according to this procedure. Okay, so basically it talks about the testing scenario wherein rising stem valve fitted with graphite packing. Okay, right. That is again ultimately to reduce the fugitive emission. Then we have APA 641. This is basically talk about the quarter 10 valve. Okay, for the fugitive emission test. So these are all about the fugitive emission, friends. I have given the whatever the needed information, and of course in each aspect, like ISO 15848 part 1, we talked about the procedure, right? So the procedure, how they are doing their testing, and also the acceptance criteria, all those that API detailing, all are there actually. And of course, if you are interested, let me know and comment, then I can, plan for that. Otherwise, I'll just wind up with this. Okay. Thank you for watching. Take care. Bye-bye.